We've spent a lot of time talking about closures, but didn't touch on a very important subject. How do we deal with errors that arise inside a closure or a closure expression? There are a couple different ways to deal with this, and it mostly depends on who wrote that original function to begin with. So let's start simple. I have a new playground page, and in here we're going to define a different version of our apply function that we wrote earlier. So this will be an extension on the int type, and we'll say func apply some value int, and then the second argument is an operation type int to int, and then finally the entire function returns an integer. In here, all we're going to do is return the application or the result of applying operation to self and the value passed in. So this time, compared to before, apply takes a value that we want to apply in some way to the actual integer value since this is an extension on the int type. Operation now takes a closure expression that takes two integer values and returns an int. So apply returns the result of applying the operation on self and this new value. And using this function, we can now write simple math operations like this. So we can say 10.apply 12, and since this is a trailing closure, we'll say $0 plus $1. Cool, this works. We get so happy with this function that we've written that we give it to our coworkers. Except you forgot that the first thing developers try to do is break other people's code. So someone comes along and writes code like this: 10.apply 0. What was that? Okay, let me get rid of that. And for the closure, they're going to say $0 divided by $1. Oops, this is going to cause a runtime error and our program crashes. Pretty hard. Dividing by 0 is impossible. And this is what we're doing here. We're dividing 10 by 0. To counter these kinds of things ever happening, we'd like to allow the caller of the function to throw an error if they want. Just like we can mark any function as throwing, we can mark a closure expression as throwing as well. And we do that by adding the throws keyword, and this is our closure. So again, before the return type, I'll say throws. But now the compiler is going to complain because we're not using try over here to evaluate our expression. We have two options here. One is to handle the error inside the apply function itself. We would do that like we normally handle errors. So we would get rid of this, and we would use a do try catch statement, try the operation, so apply operation to self and value, and then we'd catch the error. As always, just for the purpose of this example, we're going to have an empty catch block. Do not do this in actual code. Okay, so now inside this function, we're handling the error, right? And, well, this is not working because we need to return this, return try operation. And we still have an error, and I think I am missing a brace somewhere. Oh, no, never mind. That's because we haven't accounted for the case where we run into an error. So we're somewhat handling the error, but not really. There's two problems here. Again, as I mentioned, the apply function isn't happy because it expects us to return an integer value. And as always, simply returning a random value is poor programming. For example, if I were to say return 1 at the bottom just to satisfy the compiler, this is pretty bad, right? This is bad code. The second problem here is that we're handling the error inside of the apply function itself. Since the operation method is determined when the apply function is called, by handling the error inside my function, my only option is to have an empty catch block because I don't know what kind of error we're going to end up with. I can't conceive of all the different errors that may occur here, so my only option would be to crash the app with a fatal error statement here. And all of this is just poor choices all around. Now, one way I can improve my code is by saying that the apply function is a throwing function as well. So here I'll say throws. Now I can change all this. I can change the body of the function to say return try operation on self and value. This way, if the operation succeeds, then we get a value back. Otherwise, we propagate the error to the call site. So let's get rid of this code and see how the addition of a second throws helped. Can we solve the problem of this coworker who is trying to break our code? So now that we have the second throws, instead of just failing, we can use the typical error handling mechanisms at the call site to throw an error from within the closure. So we'll define an error. We'll just call it math error of type error. Case divide by 0. And we can use this now in our closure. We can say do try 10.apply 0. And then we'll use a trailing closure here, and we'll say if $1 equals 0, throw math error dot divide by 0, else return $0 divided by $1. And then below, at the end of the do statement, we'll include our catch block, and we'll catch on that specific error, 0, and we'll just print error. As you can see now, it says error. Using the try keyword, because our new version of apply can throw, we can pass in a closure, and from within a closure, we can throw the error. Because the outer apply function then simply propagates that error up one level, we can catch that error outside of this do block and do something with it. Okay, so problem number 1 of how to write a closure that can throw seems somewhat solved. Now, like with normal error handling, we can put this inside a do clause as we've just done, use a catch statement, and catch on that specific error. This you should be familiar with. But there is a bit of a subtlety here, and we'll check that out in the next video.